All right. Well, we're going to come to our third and final example of how to determine when a curve has a tangent. And we want to figure out, does this curve have a tangent at x equals 0? In the previous two examples, we identified when curves do have tangent lines. And we, once again, wanted to figure out if it does have a tangent by using an alternate form. If we take the limit as x approaches, in this case, 0, so our c value, all right, of the function f of x minus f of 0 over x minus 0, all right, if that exists, then this has to be true. Then the limit, because this is the slope, remember the slope formula, as x approaches 0 to the right of the function, slope, f of x minus f of 0 over x minus 0, has to equal the limit as x approaches 0 to the left of the function, f of x minus f of 0 over x minus 0. So to determine if that is accurate, okay, I'm going to put this up here, all right, and we're going to go through this process to determine if this is true. So the first one, we're going to take the limit as x approaches 0 to the right. Well, to the right would mean that we're going to be taking the values, all right, just to the right of that 0. So that would be x is greater than 0. So we're going to use this function. So we're going to take the limit as x approaches 0 to the right and find the slope when it's to the right by taking the f of x, 2x plus 2, and subtracting f of 0, which is going to give us 2. All over x minus 0, which is just x. By doing so, we have x over 2x, and that's going to cancel out. We take the limit then, as x approaches 0 to the right, and that's going to equal 2. All right, so we found out that the slope to the right of the function, or the right of 0, is 2. Now, in all of our examples, we found out that they always seem to be equal. However, as we go on this one, and we look to the left of this function, to the left would mean all values less than 0. So right here. If we take this one, and we take the limit, as x approaches 0 to the left of f of x, will be 2 minus 2x minus x squared, minus 0, and once again we have 2, okay, so that's good, it's continuous, and we have all over x. Well, in doing so, we cancel. Now we have negative 2x minus x squared over x. We see something strange starts happening because we have x right there, factor in x, cancel. Limit as x approaches 0 to the left, however, in this case, is negative 2. So the limit as we approach here is 2. As we approach here is negative 2. Because we approach two different values, what happens is that this right here, there's what we call a corner. We'll look at that graphically in 1 second, but this will be a corner. But these two are not equal. Therefore, when does the curve have, is there a tangent at x equals 0? The answer in this case is a resounding no. The slope to the right is equal to 2. The slope to the left is negative 2. We can see this graphically if we take our graphing calculators. You know, take this out, and we graph these two different functions. I have to delete all this stuff. But if we take this and we say, okay, we have 2 minus 2x minus x squared. All right, and we can actually take this and we can go and say, okay, x is going to be less than. We go to math, and where is it? Bars, let me take the test. Never mind, I should pause it. Sorry about that. I didn't know where I was going. All right, now I found it. All right, if you go over here and you want to find your test, you go second, math. There it is. Many of you probably knew it. We're going to take it, going to be less than. So I'm going to actually graph this on my graphing calculator. Look at that. All right, less than 0. And we're going to take the other part. All right, we'll graph the second one, which is 2x plus 2. And we'll put our parentheses right there. And we'll put this one where it's going to be x is going to be, second math, and we're going to have greater than or equal to 0. And close that. And we'll have that right there. We'll graph these. So our first one is going to be the parabola, which is going to stop right there. And actually, I graphed it pretty much all together. So if I could take this Hello. Oh, well, it didn't really do everything for it that we wanted to, but in any case, what we have right here, all right, in any case, is when we graph this parabola, okay, is we have this part, all right, where it's going to graph all the values which are, all right, less than 0, okay. And then we have our other value, which is going to be greater than 0, it's going to be right here, okay. But we notice that right there is that there is actually a corner. And corners occur, all right, corners occur when these two values to the right and left when they do not equal each other. And so that's what we have, all right here, and why that tangent doesn't exist. Now, another example of where the tangent doesn't exist is if we had another example of something like so. All right, if we have f of x equaling sine of x, and for all x values from here, x is going to be 3 pi over 4, and let's say we had cosine of x, and we have 3 pi over 4 to 2 pi. Okay, and we're going to try to figure this out at x equaling 3 pi over 4. Now, by doing so, and looking at these different values, okay, and plugging this in here, what we're going to do is we're going to check this out by identifying, all right, what those values are going to be. Well, 3 pi over 4, if you recall, is over on this side, okay? So if we take, and we want to first find out this, is if we would go through in the same process, but you realize that when we plug in f of 3 pi over 4, you realize that the sine function, when we plug that in there, because you know in our equation we have to have the same value, all right, for both the right and left side of 3 pi over 4. So we're going to plug in the sine and cosine, but they have to be continuous. It has to be continuous. But when we plug this in to the top and bottom, 3 pi over 4 on the here is going to be a positive value, which is actually going to be positive square root of 2 over 2. However, cosine, all right, is actually going to be negative square root of 2 over 2. These two values are different. Because they are different, we know that this function f of x is discontinuous at x equaling 3 pi over 4. Because it's discontinuous, you cannot have a derivative there. Okay? There has to be continuity in order to have a derivative or a slope, right? Because you're approaching two different values, and therefore there is no derivative. So right here, because of discontinuity, this is another example of where you do not have a slope of the tangent. So where there's discontinuity, and where you approach two different values or two different slopes to the right and left of a point, that is when a curve doesn't exist, okay, or a tangent doesn't exist on a point of the curve. I hope that was okay. I'm sorry about the little glitches with the graphing calculator and whatnot, but hopefully this you found some information you need of when now functions do not have tangents at the given points. All right, at corners and also at discontinuity. All right, so good luck in the rest of your problems, and God bless.